Okay, here we want to look at how can we find the derivative of the natural log. And our formula for taking the derivative of the natural log is very straightforward. It says that we're going to let u be a differentiable function of x, okay? And it says that down here, if we want to take the derivative of the natural log of u, now remember, u is not just a variable. U is actually some function of x here, okay? And it says we want to take the derivative of this natural log of u with respect to x. So this is d dx. This means we want to take the derivative of ln of u with respect to the variable x. And to do that, we're simply going to take the derivative of u, okay, du, that's the derivative of u, and we're going to divide it by u. And that's all that it is for finding the derivative of the natural log. So if we look at a very basic example here, the natural log of x, so here we're taking the natural log of x, and if we want to find the derivative f prime of x, then that means here our u is simply x. So up here this says u is a function of x, so here u is simply equal to x. So we need to take the derivative of u. Well, the derivative of x would simply be 1 over u. Well, our u is x, so that's just simply 1 over x. So anytime you take the natural log of just simply x, your derivative is going to be 1 over x. All right, let's look at one a little bit more involved, the natural log of 2x squared plus 1. So here, the 2x squared plus 1, all of this is our u. So if we want to take the derivative, then our formula says we want to find the derivative of u, and the derivative of u would simply be 2 times 2 would be 4x, and the derivative of 1 is 0, and this is all divided by our u, which is 2x squared plus 1. And that's it. That's our derivative. And you're probably thinking this almost seems a little too easy, and in a way it is. I mean, you're just simply taking the derivative of u and then dividing by u. All right, now you may want to stop the video and see if you can figure this one out. We have f of x equals x natural log of x. All right, so hopefully you did pause the video and try this one on your own. So if we try to take the derivative here, there's one important thing you need to realize. Where you have x ln of x, this is actually being multiplied x times the natural log of x. So here we're going to have to use, the product rule. Okay, now I know it's been a while since we've done some of this differentiation because we've been looking at a lot of integration, but we have to go back and use the product rule. And if you recall, what does the product rule say? Well, it says if we're taking d dx of u times v, then you're going to take the first multiplied by the derivative of the second plus your second piece multiplied by the derivative of the first. So here's our product rule. U times v, first times the derivative of the second plus the second times the derivative of the first. So if we want to apply that here, we have x ln of x. So we're going to take our first piece, which is x. We're going to multiply that by the derivative of the natural log of x. Well, that's simply going to be the derivative of x is 1 over x plus ln of x multiplied by the derivative of x, the first piece, and the derivative of x would simply be 1. So we could simplify this. X times 1 over x is going to go to 1 plus the natural log of x. And this here would be our derivative. Okay, so I hope you understand here this is fairly straightforward. Finding the derivative of natural log, you're simply taking the derivative of the u, whatever you're taking the natural log of, the derivative of that piece divided by your u. Okay, and the next video we're going to look at some examples that are a little bit more involved. So you can practice some of these basic examples out of your book and then continue on to the next video.